Hi, welcome back to DevOps series. This is Satyadev. In the last presentation, I talked about ITIL and DevOps, and then DevOps and Agile, how they work together, how they complement each other, and all these things, we have seen. Now, in this presentation, I'm going to talk about the actual DevOps phases. What are the various phases that are there when it comes to, kind of is interacting with the Agile, and how CI/CD works. I'm going to define CI/CD as well in this presentation, and we'll see that. Now, before going that, as I explained in the very beginning that we talked about waterfall model, then we talked about how Agile refines waterfall model, and we also seen where Agile has what Agile has clearly defined, what Agile hasn't clearly defined, and where and how DevOps can take care of the places where Agile hasn't done in a good job. So that's what we have we have discussed. But how actually how things would happen when it comes to Agile and DevOps linked together, how things would work together, and what is CA, what is CD. We are going to have a understanding of those things in this presentation. So let's go to the next slide. Now, build activities in development. So when in the Agile model, we have seen there are 4 kinds of activities when it comes to development team. So coding, testing, deployment, and monitoring. Like monitoring basically is nothing but maintenance. Maintenance, when it is being maintenance, it's running, and just take care of, look into that how things are going, and then monitor. 4 phases have been defined in the Agile model. That's where actually DevOps also comes into picture, because the main aim of DevOps is to make sure that all these phases work as fast as possible, so that we will get the code as quickly as possible. Now, with Agile model, like I said, development, testing, deployment, and maintenance are there. Now, the build process, the code building process in Agile model is not defined as a separate process. It's part of the code development, or it's not a separate part. It's part of the code development, like I have shown in this. In this thing, right? So four steps are there, or 4 phases are there. However, in reality, when it comes to coding, yes, it's like use a programming language like Java or C# or Python, whatever it is, write the code, right? That's what coding. But once the code is done, based on the architecture, it could be a microservice architecture, it could be a 3-tier architecture. It depends, right? So there has to be separate components that needs to be built. So and again, those components maybe if it's a Java, it has to be in a jar file. If it is a .NET, it should be a DLL file or exe file. But that's not enough. You have to create an installer, right? So because in order to test engineers to test, we can't just pass the exes and binaries. We have to provide an installer so that they will understand how the installer is working, or the execution is working fine, all these things, right? So building is not just compiling the code. It's like getting the release version of the things with all the set correct configurations, and put it into an installer, and then expose it to the other teams. Like for example, if it is a small team, yes, giving it to test and a small project or small application, yeah, it's okay to give it to the developers. But if it is a huge team, which is spread across geographically, or several teams, we have to provide an installer, and you can't just pass the installer through emails or put it in a folder. You have to expose it in a through a server, so that people can download. So even customers also will download from a server, right? So which is called an artifact server, which I will talk about later. So that's what it is. So build is not a small activity, even though people overlook that activity. It's not a small activity. So, and because it's a kind of good big activity, it takes time. Now, the main goal of DevOps is, wherever the things are not happening faster, make it faster. That's pretty much what the DevOps goal, right? So make things faster. code part, yeah, coding depends upon human being, but coding also requires as part of coding, before going to the build part, you had code reviews and all these things also need to happen, right? That I will talk to in little later, but yeah, that also has to be automated. All these things we are going to discuss now. So build process actually requires significant manual effort and is hindrance to quick delivery. So what DevOps does is that make build also as part of the separate, as part of the development, as part of this DevOps chain, like code, build, then test, deploy, and monitor. So sometimes deploy is kind of delivery and deploy used, checks interchangingly, but there is a difference. I will talk about that in this presentation itself. So let's go to the next slide and see what are the various activities that happens in part of the build, because it's something like newly introduced now, right? So original agile only defines 4 phases apart from analysis and design. It defines only 4 phases like code, test, deploy, and monitor. But agile adds this build phase. So let's go see about what build phase is. Now build has got 3 aspects to it. One is the activities that happen before building, during build process or build activities, and post building. Now pre-build activities are like code synchronization, like like I said, in a project there could be multiple developers working on multiple pieces of the code, right? The code has to be integrated into one code repository. So like let's say 2 programmers are working on the same file. They made modifications independently, but they push the code to the Git repository at the same time. So there would be a conflict for one of them, right? So it has to be for both of them, and it has to be resolved. So resolution of the conflicts and all these things has to be done. That comes under code resolution, synchronization. Merge conflicts, kind of the same thing. Dependency management, local dependency installation. Basically, if the products are using certain version of this, some DLs or something like that, make sure they are there, because development machine could have a lot of things, right? So they experiment so many things, they have a lot of applications going on, so different versions of DLs should be there. So when it comes to building, it should make sure that whatever appropriate versions of the files that has to be there, DLLs or jar files or whatever it is, right? They have to be there exactly like that. So we have to make these things, and again the code review is part of the pre-build activity. So these are all the pre-build activities. Now as part of the build activities, executing build commands, basically compiling and making sure that the building is happening. Once the build is done, as a last step, make sure that unit tests are run for the changes that have been made, which is very, very important. Again, I'm going to talk about unit tests in this coming presentations, but what are unit tests? Are nothing but they just test the changes that have been done, and make sure that they are not breaking anything. They are working as per the expectation. That's what unit tests. Talk about more in the coming presentation. Locating the build artifacts. Now, basically artifacts I'll define later, but nothing but the outcomes of the build. DLLs or EXEs or now, and once they are done, they have to be put it into install. Versioning the artifacts. Make sure that the artifacts are properly versioned, because they shouldn't be conflicting with the older versions, right? So, and these are the build activities. Now when it comes to post build deployment, it could be, I said manual, but it could be manual or automatic. In automatic, I think most of the things can be done, but there are certain challenges for making the deployment automatic. I'll talk about that later, but yeah, if it is a manual deployment, make sure that server restarts, sanity checks, and everything is tested properly. Notify the team that yes, we have installed new version. Creating release notes for the customers. Publish the build so that the customers will take. So these are all the activities that happen. Actually, in software, these are all activities development do happen. In olden days, these are all manual. Used to take a lot of time. The DevOps idea is to make sure that they are all automated. That's pretty much what it is. So these are all the build related activities. Now, let's talk about making them faster. Right? So DevOps, how DevOps can can make the slower things faster. Now let's see the definition of DevOps. DevOps technical goal of DevOps. So DevOps technical goal is to increase the deployment frequency by reducing time between committing a change to the system by dev team and bringing it to the production by the IT team. IT means like IT ops team, while ensuring high quality software. Now this is what we have been discussing, right? So in the when I defined DevOps, I exactly said the same thing. Basically, as soon as a developer is done with all the developers are done with changes and code is checked in and labeled, then it should automatically build, and by the IT team, and IT team should get it and make sure that whatever that is built is with high quality and it has to be provided to the customers. That's pretty much the goal of and it should be in a quick manner. I think reduce the time. That's what the goal, right? Is as soon as the developer is done, shouldn't take long time to get it to the customer, right? So because of the previous processes, right, what we have defined, like release notes, manually publishing a build, all these things will take a lot of time. Building the installer, DevOps idea is to minimize those things so that it should work. Again, coding you can't reduce the time because it depends upon that until now. But with AI and machine learning things, there are so many tools coming up. Even the coding activity is also getting automated. Earlier, only testing is being automated. Now, development also is being automated. So, I mean, maybe something that needs to be added to the DevOps as well. It will become part of DevOps in the future versions of DevOps. Now, there are three aspects we have discussed. Improve the code quality, improve the product delivery build speed, improve the product deployment speed to different environments. So these are the three aspects where could take time. Because when I say code quality, it is about code review and checking the following standards or not. These are all the stuff, right? So we have to improve those three things, mainly three things. Now, to improve the code quality, like I said, the code review, validation, testing, all these things should happen. But in order to make it faster, what we need to do is automate it. Basically, automation is pretty much what is required, right? So automate the code quality check process. Like code reviews needs to be automated, validation needs to be automated, testing needs to be automated. So once we do that, it's good. Then second step is product delivery building speed, like code building activity should be building. We already talked about what are the building activities, right? So compiling the code, creating the outcomes, creating the installers or artifacts, publish to the artifact server, all these things. Until recent, until DevOps was there, these are all being done manually in order to increase, which it could take like 1 or 2 days of time, which could be eliminated by automating it. Again, automate the build process. And the third aspect is activity could be a deployment process. Well, there are certain challenges to it, but after honestly, deployment, I would say, could happen at two stages. One is at a testing stage, another is at production stage, right? So testing, in testing stage there are so many things, kinds of testings are there, which I will talk about later. But that means once the build happens, the installer is there. What the testers would do is they manually download the installer, double click on it, and install the product on their machine, and they test it, right? So again, this is manual process, so it could take some time, right? So, in order to make that happen, the deployment activity, which is actually deployment is, right? So also should be automated. So deployment could happen at two places, predominantly. One is for testing, and other is for the production where customers use that. So those two has to be automated, because production may be one time job only, but whereas testing could take multiple times, because if they find any issues, again the developers have to fix that, and again the deployment happen. It could take a lot of time, number of chance, right? So I mean, don't want to waste every day for each deployment, so let's get it done automatically. That's what deployment automation means. So above three actions lead to three aspects of DevOps, like one is continuous integration, continuous delivery, and continuous deployment respectively. Now the first part is continuous integration, second part is continuous delivery, and third part is continuous deployment. Here I am going to talk about the subtle difference between delivery and deployment. Continuous delivery means creating the installers. That means yes, we have got the final thing. Now that is continuous. That should be like a continuous process. Whenever developers is done, should be automatically automatical code review and all these things, and boom, installer should be there as quickly as possible. Now deployment is something like okay, installer is there, but the testers have to install their machine. Once everything is good, it has to be put into staging. Then it has to put into this um, into production environments, right? So that's what actually deployment means. Installing the product from the installers is the deployment phase. So that's also has to be automated. So CACD basically stands for, actually people say CACD, there is another CD actually: continuous integration, continuous delivery, and continuous deployment, right? So yeah, that's what I have defined here. What are those things? Continuous integration. In this phase, developers frequently integrate their code changes into shared repository, sometimes multiple times a day. Each integration triggers automated build and tests to catch issues early. The main goal of continuous integration is to ensure code is consistently stable by detecting bugs or conflicts quickly. Now, here I want to talk about one important aspect. Now, in the text that I have written, said like developers could make changes to the code every day. Now, is it really necessary to build code based on code? Let's say I'm writing a program. I made some changes now and I checked in. Now, after 30 minutes, I'm doing my testing. I found that there is a problem and I fixed it. Now, I checked in the code again, right? Like after 30 minutes. Again, after 1 hour, I did the same thing. Like throughout the day, I've been making modifications, checking, all these things I'm doing. Now, each time I check in, is the build needs to happen? Is it necessary or not? Now, it depends basically. Most of the time, honest answer is no. It's not needed for every check-in. But at the same time, whatever I checked in, it is not guaranteed that it's going to build, right? Sometimes, developers maybe knowingly or unknowingly, they check in code which is not syntactically correct. That means if somebody gets that code, their program won't compile, right? Now, two options. Either that guy will ask the first guy who has checked in the code with wrong syntaxes as to fix it, or that guy has, yeah man, this guy has done it and he has to check in himself, fix that and check in. That's not, which is not a good practice, right? So, I think these kind of things could happen. So that's the reason check-in may not happen. Check-in might happen immediately. Now, further, there is an option. Git has got a way of getting things done called branching, right? Now, normally what developers will do is, if they are working on piece of code, they have created their own branch and they work in that branch for that module or use case or story that they are working on. Once they are good, once they compile everything, then they will give it to the code review. Code review happens sometimes happens on the branch of the developer, not on the main branch. So once code review is done, then they will ask the developer to check in the code. Yeah, everything is good, you check in. Then the developer will put into the main branch and then the check. So basically, using the facilities provided by Git, whenever code is checked into the main branch of the project or product, yes, the build should happen. But the build doesn't need to be happen for each user developer check-in, because developer could keep checking in every day. But in some organizations, they have a way of, they are okay to do that. It depends, but most of the time it is not necessary, but it does happen in some organization because they want to find out who are the developers who are breaking the build. So everybody checks into the main branch. So that's some organizations follow, which is like XP, extreme programming in a common standard. That's what CA, continuous integration. Next one is continuous delivery. In this phase, build deliverables are automatically prepared for release into production. These deliverables are always in a deployable state, such as an installer, but deployment to the production is manual. Goal is to enable reliable, frequent release with minimal manual intervention. Now, as I said, continuous delivery stands for building all the DLLs or EXEs or jars or whatever it executables is one aspect from the code compiling, then pushing them into making them as an installer the buildable thing. Just take one piece, you just click one button, it will take care of installing all the right versions at the right places and make sure that things would work properly. Configurations, settings, everything it will should take care of, right? So that's what installer is. So continuous delivery talks about the goal of continuous delivery is to make sure that minimal and manual intervention has to be there for getting the install. Now continuous delivery doesn't talk about installing for the test machine and installing the production machine, because that's could be that could be a manual thing or it could be an automated thing. When it is automated, it is called continuous deployment. In this continuous deployment, deliverables are automatically deployed to production, honoring any special needs such as initial scaling, load balancing, etc., etc. Some organizations, they go for continuous deployment, even though there are certain challenges, which I'm going to talk towards the end of this unit. Continuous deployment challenges. Some organizations go for it. So as soon as a developer checks in the code into the main branch, build happens, build will get into the build output converted into an artifact, and then they will be installed into a test server. They will be tested automatically in the test server, then they will put out to the production server automatically. So this is how it happens, right? So this is what CID. Now just let's in the CI/CD perspective, how these 5 steps in DevOps work. That's what we are going to see. Here is how DevOps phases are mapped to CI/CD pipeline after separating build actions from code activities and instated as a special and a separate phase, right? So no, this is called CI/CD pipeline because the flow is sequential. Well, again, I say sequential, but it doesn't need to be because in the deployment phase, it could be first deployed to test fails, then it goes to some other test, it goes to some other test, then it will go some other test, then it will go to staging, then it's go to production. That's the last stage. So it could be like multiple parallelly. They could happen, right? So it's sequential. It's like it's like a pipeline. When you say pipeline, pipeline normally goes straight, but from there are joints, right? There are joints to the pipeline. Go to some other places. It could, and there are controls at these joints. Like want to go it or do you not want to go it? Like that, CI/CD works like that way. It's like a pipeline of things. Mostly it is sequential, but there are sub pipelines. For example, in case of deployment where there are multiple test machines, the deployment could happen parallelly. That means there are from this pipeline you have sub pipelines kind of thing, right? So and there are controls. You want to do it, you don't want to do it, that kind of thing, and it will happen. Once everything is done, install in the production server, then monitor it. And also, okay, not just installing production server. How many instances you want? Like 10 instances or 1 instance? So predefined configurations. All these things have to be taken care, right? So that's what the pipeline is. Now, you see the picture, like code, build, test. They come under continuous integration. Now, of course, the test requires deployment, but it's part of the continuous integration process. Again, like I said, delivery is different, deployment is different. Sometimes, when the installer is there, it might not take a lot of time. So people might go and install manually. So then it becomes a delivery, continuous. It's part of continuous. But once it is deployed, and into production, and it's being monitored, it comes under the CD part, continuous deployment part. Now, when there is no deployment, then it is the CI/CD is called continuous integration and continuous delivery. When there is deployment, automatic deployment, when I'm talking about automatic deployment, then it is called continuous integration and continuous deployment, right? So like I said, each of the CI/CD pipeline phases involves actors, components, procedures. So again, each one like code, build, test, deploy, monitor, all these things will have several other subcomponents, right? So let's see what are those components at a high level. When it comes to code, which is part of the CA, developers are one actors, unit tests are another actors, code review which is a procedure, is another thing, and dev and sandbox. Dev is nothing but the developer machine. The sandbox, I'll talk about it, what it is. That's what the description says. So developer means people who develop the code. Unit test means tests written by developers to check isolated functionality. Code review means like process for testing the code quality. Dev sandbox, isolated test environments for POC and dev testing. Now, the build phase, which is also part of CA, continuous integration, the revision control system, place to store collaborative code written by the multiple developers, build server component, which is like binaries for the code, artifact server is server that publishes the installers, package managers. So package managers won't have any separate thing, but they actually make sure that whatever that is required for a build to happen, they will provide it. That's what I'll talk about that in this presentation. Again, test, QA environment, the server that QA team works on, the staging environment, one step before we put it into production. That's where the user acceptances happen, which I will discuss in the coming presentations. Production environment for users, customers who use production product, and then that completes the CA part of it. Now, delivery or deployment. As I told you, deployment, when it comes to installation, there could be some scripts that needs to be written, right? So the deployment scripts that automatically puts product into staging and production for a continuous deployment. Release management procedure, process involved in pushing the release details to the outside the world, all these things, right? So this is about delivery. And monitoring tools, like tools to monitor the product, how it is working, like I said, Grafana and all these things, right? Elk Stack, those are all monitors. So these are all about CI/CD. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.